Okay, we're ready to start combining two concepts. We have learned about all different types of reactions, chemical reactions such as acid-base reactions, oxidation-reduction reactions, and we're going to take that information and combine with it the calculations that we've learned along the way, how to go between grams and moles, for example. We learned about how all roads lead to moles. We can get to moles from all sorts of different places. So we're going to put those things together and cover what's called reaction stoichiometry. Reaction stoichiometry is a way of answering how much, okay? It is a quantitative, okay, we'll put that up here, quantitative study of reactants and products in a chemical reaction. Quantitative has the word quantity in it. Quantity is how much. So you want to form 5 grams of product, how much reactant do you have to start with? You have 13 milliliters of this reactant, how much product would form from it? So it's a way of relating the amounts, okay? To do this, we have to learn one more tool to put in our tool belt. We've learned a whole series of different conversion tools along the way. We're going to learn one more. To learn that one more, let's consider this chemical reaction. When we have this reaction, hydrogen plus oxygen going to water, we can think about those numbers in the front, which we learned how to balance these. We can think about those coefficients in a couple different ways. One way we can think about it is in terms of molecules. Okay, so we can think about this on the molecular level. What do I mean by that? Well, we would say 2 molecules of hydrogen reacts with 1 molecule of oxygen to produce 2 molecules of water. Okay, so that's one way to think of it in terms of the molecular level. Or we can up the scale and think about it on the mole level. The mole level is much more realistic because you can't hold 2 molecules of hydrogen in your hand, force it to react with 1 little molecule of oxygen, but you can do it with the mole. So you could say, all I'm doing is upping the scale. 2 moles of hydrogen reacts with 1 mole of oxygen to produce 2 moles of water. And this is the way we will think about it. It is not that the other one is wrong. It certainly isn't wrong. It's just more convenient for us to think about it on a scale that we can actually work with while we do calculations. Okay, so let's proceed. We're taking that same reaction, and you see it down there in the bottom. That reaction, I'm wanting to scale it up. So instead of having 2 moles, okay, reacting with 1 mole to produce 2 moles, I want you to up the scale. And we have 4 moles of hydrogen reacting with 2 moles of oxygen. If you were to do that, I want to know how many moles of water would form. Now you're just letting your logic work for you here. I think you can do that just fine and come up with an answer. Well, hopefully you came up with the answer 4 because you noticed that everything was just doubled. Instead of 2, we had 4. Instead of 1, we had 2. So instead of 2, we have 4. And that would be our answer. But we want to see this as the tool it really is. The tool that it really is, okay, is a new unit factor in which we use the coefficients in our balanced equation to convert from moles of one substance to moles of the other substance. That's really the biggest conversion that we do when a chemical reaction takes place. If we know one substance, then we want to know the other substance. So this is going to be a unit factor. So let's go to the light board here and show you how I would do this type of problem with my conversion factor. Let's say I had given to me that I had 4 moles of H2. And I didn't want to know moles of H2. I wanted to know moles of water. Now what I would do then is go to my balanced equation. And as I look, and you might have to look back in your notes to see that. Actually, I can flip back one. I think, here. Okay, there it is down at the bottom. I look at those coefficients, and I look at the coefficient in front of H2, and it had a 2 there. And I look at the coefficient in front of H2O, and it had a 2 there. So that tells me it's 4 times 2 divided by 2, and that would give me 4 moles of water. Now, you wouldn't have had to use this conversion tool to answer the question that I gave to you. You just noticed that everything was doubled. But a lot of times we're not working with such simplistic numbers. We're using much different values, and it's not quite so straightforward. And we want to be able to attack this one conversion in the midst of a bunch of different conversions that we're doing along the way. All right, so we've got, oops, I'm going the wrong direction. Forgive me here, guys. That's what we were up to. Now, down here at the bottom of this screen is our new conversion that we just learned to go between moles of one substance, which I called moles of A, to moles of another substance. I called that moles of B. All the other ones are ones we've learned along the way as we've been doing calculations. Now, I've taken those conversions that we see here in this table and I've put it into a map, because being able to solve our problems, we have got to be given one thing about a chemical reaction and we're asked to go somewhere else in that chemical reaction. And we can follow this map. So, let's just look at the map. Known country is what you've been given. It's doing it again. Here we go. Go back, baby. So the known country will be what you're given in the problem, and the unknown country is what you are trying to determine, okay? So this is the substance for which you are trying to determine something. They're going to, when you're reading a problem, they're going to lay you somewhere down in this map. Now, we got familiar with half of this map in class and how all roads lead to moles. But the only way you can travel from known country to unknown country is by way of our bridge. So we've got our coefficient bridge placed here. Now, we could do it from moles to moles, which is what we typically will do, okay? You can do it from actual number to actual number down on the individual molecule scale if we wanted to. It'd be the same coefficients because we learned that those coefficients can go either way. So now, we had learned previously how to go from grams to moles. Okay, we learned that conversion. We learned how to use molarity and volume to get to moles, so we have different routes into moles. And once we go over the bridge, we can get back out to what's ever being asked of us. Okay, so we have our map to help us solve our problems. Now we're going to look at a problem where in this case we're given that we have 4.5 grams of hydrogen and we're trying to figure out how many moles of of water would react with it. So we're starting with grams of H2 and we're trying to go to moles of H2O. So we start by writing what we were given, 4.5 grams of H2. Now, the first place I want to go is to moles. Remember, all roads lead into moles. So I'm going to go to moles of my known. We're still in the blue country. So I'm going from grams of H2 to moles of H2. And I go get the periodic table out and determine the molar mass of hydrogen. And the molar mass of hydrogen is 2.016. It goes with the grams, and a 1 goes with the moles. That got me into moles. I'm ready to go and discover something about my unknown. My unknown in this problem is the how many moles of water. So I'm trying to go to moles of water. So I'm going to go over the bridge. I cancel what I don't want, moles of hydrogen, go over the bridge to moles of what I'm looking for. And in this case, how many moles of water they're looking for. So we go back to our thing. We're going over the bridge from the blue to the yellow using moles. Now, the balanced equation is where I get the relationship here. And in front of the H2 was a 2. In front of the H2O was a 2, so those are the numbers that are there. Now I'm going to take 4.5 divided by 2.016, and that's going to give me 2.23, and to 2 sig figs, we just write as 2.2 moles of water. So we've used our map and plotted out our journey and taken the steps that we needed to take. All right, look at it one more time. We start on the far left bottom where it says grams. We went to moles. We went over to moles of the water and we stopped because that's what was asked for. All right, now in this problem, we're going to start with, what's the given? We're starting with 2.0, and look at the units, grams of, and the substance. Remember, if I could get students to do this, I will have accomplished something. Don't just write grams. Write grams of what? And write your substance because we're changing substances in the course of these reactions. Now let's look at our map. Well, that's where we're trying to go first. How many grams of water? So, if we look at our map, we're starting in the blue at grams. That's grams of oxygen. Okay, that's where we're starting. Where are we trying to go? Over to the yellow zone, the unknown, and that's going to be grams of, what's grams of? We're trying to get grams of oxygen, so that's my unknown. So we're going to go grams to moles in the blue, over the bridge to moles into the yellow, that's the unknown, and then on out to grams. So I'm going to have 3 roads and bridges to travel on. All right, so let's do the steps along the way. I'm going to first go to moles. I don't want grams of O2. I want moles of O2. You go to the periodic table, O2, it's 2 oxygens. So it's 16 times 2, or 32 grams in a mole. Then I'm ready to go over my bridge from moles of the O2 that I don't want to moles of what? What am I looking for in this case? How many? I'm asking about water, so I'm going to go to moles of water. We look at our balanced equation, and in front of the water was a 2, and in front of the oxygen is a 1. So now we have gone over our bridge. But we didn't want to stop at moles. We want to continue on our journey from moles of water to grams of water. And we go to our periodic table and we add up the molar mass of each of those things, and that will give me the value there. So now I'm going to take 2 divided by 32 times 2 times 18.015, and when I put those values into my calculator, I will have a value of 2.3 grams of water. And that is a very typical stoichiometry problem at this point in your world, where you're starting with grams of one substance and trying to get to grams of another substance, and you go by way of that bridge to get you over from one to the other. All right, so this is our new step. We've learned how to convert between moles and moles. What we're going to do next is what's called a limiting reactant problem. There's really no new calculation. We're just going to look at a new environment to put these calculations.